Yes. Hello, everyone, and welcome to our next series of webinars, which we are having on citizen science. And today also is the day of International Day of Women in Astronomy, in STEM, and for women and girls in STEM. Though obviously we will concentrate on astronomy because that's our personal bias. So we'll be talking on that. And to start off on our program, we have actually invited Stella Kafka, who's with us, who's going to start our celebration. And our celebration is not going to end today. We are basically going to have 5 sessions. And essentially what we are trying to do is we are trying to highlight citizen science and how women, girls, and everyone in principle can get involved in citizen science projects. And some of the citizen science projects which we'll be showing you are ones which do not require much of prior skills, in the sense of you don't need to know coding or you don't need to have too many technical skills, but you can still be involved in astronomy and astrophysics. And that's the basic purpose of us having these series. So to start off this series, the start today is with Stella, and Stella is going to talk to us about unsung heroes, about the many women who were in astronomy who have been forgotten. And no one better than Stella to tell us about that. So I'll first introduce her. So Stella is now the executive director of the American Meteorological Society. Earlier, she was the executive director of the American Association of Variable Star Observers, and that's how many of our participants know her, because they were involved with the AAVSO. Stella obtained her PS degree in physics at the University of Athens in Greece and a master's and a PhD in astronomy, with a double minor in physics and geophysical sciences from Indiana University in Bloomington, Indiana. There she received the Hollis and Gret Johnson Award for Excellence in Graduate Student Research. After completing her PhD, Stella had a series of prestigious postdoctoral positions and fellowships. And after that, she has a wealth of managerial experience, in addition to serving as the director of 2 research and mentorship programs for undergrads. While in Chile, Stella managed editorial, marketing, financial, business development, operations, and production aspects of journals at the American Institute of Physics, the AIP. And on top of her research and management abilities, Stella brings an international perspective to her work. After growing up in Greece, she obtained a proficiency diploma in French language. She has one in English too. She pursued higher education in the United States, worked and traveled to South America, including Chile, Argentina, and Brazil. She's fluent in Greek and English and speaks Spanish as well as French. So Stella enjoys interacting with people of every age and background and has honed her communication skills through mentoring students, classroom teaching, lectures to professional and public audiences. And like all good communicators, many of our participants who are present over here have been interacting with her since quite some time, and many of you all do know her quite well. So welcome, Stella, and we're looking forward to hearing from you about our unsung heroes.
Thank you so much. And can I please share my screen now? It's actually wonderful to be with you again, with all of you again. You're one of my favorite communities in the world. So when my friend Priya said that she wants to have a celebration of women in science in general, I didn't have to think twice. So yes, absolutely, I would definitely love to participate. So today I'm going to cheat a little bit. Since this is the first presentation, the beginning of this celebration, the celebration of not only citizen astronomy, but also women and their participation.
Sorry.
Pardon? I keep going. I still cannot share my screen, so I'll just keep talking like this. I would like to actually highlight.
1 second. I'll just give you permissions.
Thank you.
You can.
So, thank you, my friend.
Hello, please share.
Here we are. So, since today is a very, very special day, it is the International Women and Girls Science Day. It is a day that focuses on the reality that science and gender equality are both vital for the achievement of international agreed development goals. So in order to achieve full and equal access to and participation in science and for women and girls, and further achieve gender equality and the empowerment of women and girls, the United Nations General Assembly about 7 years ago designated this day as International Women and Girls in Science Day. So activities around that, other than a series like the one that my friend Priya is organizing, include 2 days of discussions for the advancement of women and girls in science, recognizing the rightful role and contribution of women in science in general, both as change agents and also as recipients of supported science. This year's theme is very interesting. It's equity, diversity, and inclusion. Water unites us. And this is actually going to be a virtual event at the United Nations. This is as an assembly, and will bring together women in science and experts from all over the world, such as high-level government officials, representatives of international organizations, scientists, to discuss the water nexus in achieving the 3 pillars of sustainable development: economic prosperity, social justice, and environmental integrity. And we know that water is essential for our livelihood. We know that life on this planet cannot thrive, cannot survive without water. We are looking for water indicators in other planets. And also, it's very related to the crisis that our planet is facing when it comes to lack of resources. Clean water, sanitation is not universally accepted and provided to everyone. This comes closer to what I am doing right now. One of the reasons why I am at the American Meteorological Society, which is an organization that advances the atmospheric and related sciences, technologies, applications, and services for the benefit of society. And I will tell you a little bit more about that towards the end. This is an association that promotes the science between weather, water, and the climate enterprise for the betterment of our society. At the same time, though, today's celebration is an opportunity to showcase and appreciate the work of individuals, of women who have not been known, whose contribution is essential actually for us. This is pretty much a quote that I took from the United Nations page. We celebrate the achievements of women known and unknown, remembered and forgotten, who have forged the way for those of us in science today, and to give an opportunity for children, girls and boys, to choose role models in science. I would love to focus on women in astronomy because, well, I am an astronomer, and we know of many women who have gone, who are in astronomy, have been in astronomy, whose role has not been recognized. But I'm going to give you some ideas of other female leaders who have contributed a lot and whose the outcomes of their work we are celebrating and we're enjoying right now without even knowing or giving them acknowledgement. And this is actually a short timeline about what we know about women in science. Historically, we don't have much information about them, although we have indications that their contribution was substantial. There's just a small group of individuals who managed to be prominent in history, especially when it comes to antiquity, and these are 2 of them. This is in ancient Greece. This is Theano. She was from a small island in Greece called Crete. None of her work actually survived, but through the works of historians, we know that she was a co-founder and teacher of the Pythagorean school, which accepted both men and women scientists, and that she wrote many works related to medicine, physics, mathematics, and psychology, especially on things connected with children. Actually, the most important of her work is the theorem of the golden mean. I'm pretty sure you're learning about that in your physics and mathematics classes, which describes the irrational number that appears in many aspects of nature. And actually, the construction of the theory is very similar to the geometrical constant pi, which was created by Pythagoras. She created a theory about the universe, and she actually her model included 10 concentric spheres: the Sun, the Moon, Saturn, Jupiter, Mars, Venus, Mercury, Earth, and counter Earth, and the stars. And actually, she believed that the stars were unable to move and everything else was moving in that particular universe. So she was actually an astronomer and philosopher who was trying to understand the world around her. Here's another one, Hypatia. Hypatia actually was an astronomer and mathematician and philosopher who lived in Alexandria, which was at that time a part of the Eastern Roman Empire. She is the first female mathematician astronomer whose life is reasonably recorded, and she was known by her. She was known and renowned in her own lifetime as a great teacher and a wise counselor. She worked on theories about the solar system herself, and she's known as the wise woman. But other than these two, we just don't know much. We know, for example, about Elena Piscopia in 1678, who was a Venetian philosopher and noble, and she gave a lecture explaining difficult passages selected in random from Aristotle, and actually his physics texts. And she actually became one of the first women to receive an academic degree from a university and the first woman to receive a Doctor of Philosophy, a PhD degree. We also know about Caroline Herschel, who is the first female astronomer to be allowed to publish scientific results in a journal. But how about others? Especially over the next the last 150 years, where technology in history and science has been prominent and has been evolving really fast. We know that, Isaac Newton said that if I have seen a little further, it's by standing on the shoulders of giants. So today I would like to mention and acknowledge those giants and tell you a little bit more how they contributed in science. And I would like to start with Ada Lovelace. She's one of the first known women mathematicians and computer programmers at a time where there was no computers. There was back in the days in 1837, Charles Babbage described a concept of an analytical engine, which would have been one of the very first computers if someone has manufactured it, if someone really did it. Lovelace wrote an extensive, in-depth analysis on the analytical engine, noting about both the technology and the larger implications of the machine. In principle, what she did was design the first computer algorithm in paper. And this is actually a copy of that work. Her work was recognized decades later. Her notes only were published only in 1953, but writing the first machine algorithm was actually the first step to make people think of how the effect and the implications of a machine like that and move forward with their own research and actually contributes and evolved computers as we know them right now. Mariah Mitchell, maybe you've heard about Mariah Mitchell. She was the first astronomy professor in the United States. She actually lived in Nantucket, which is a small island off the coast of New England. It's about an hour and a half away from here. And she was a librarian by day and an astronomer by night. Her father actually had an observatory in Nantucket. She became the first woman in the American Academy of Arts and Sciences and one of the first women employed by the US government as a professor at Vassar College. And she was known that she advocated very strongly for girls' education by bringing females to her observatory, and women were not allowed in observatories at the time. She actually discovered a comet that is known as Miss Mitchell's Comet in 1847, and she extended her advocacy to the American Association for the Advancement of Women, and actually she was inducted in the National Women's Hall of Fame in New York. But most known figures are the individuals who worked at Harvard observatories at the end of the 19th, beginning of the 20th century. even before computers were discovered, women are used as calculators in science simply because they were jobs that men didn't want to do. It was too much work, too much attention to detail, a lot of really tedious tasks to do. So those women were working as assistants to perform complex and precise mathematical calculations. This is a group at Harvard Observatory, women in astronomy who were working on cataloging data from photographic plates and or extracting photometry. They were underpaid and the work was considered to be very trivial, although it required precise mathematical measurements and analysis. And just to give you an idea what they were working on, this, um, which looks like scribbles and marks and stuff like that, this is a photographic plate of a galaxy. And what you see here, this is a globular cluster, I guess. All these little dots here are stars. So individuals, those women, were taking tiny magnifying glass and looking at each one of those dots and compare them with dots of known brightness, so assigning a brightness to them and putting them in paper, cataloging them. So all those scribbles and notes that you see are marks that those women actually put on the plates as they were continuing their work. The good thing with this kind of tedious and attention to detailed work, though, is that many novel discoveries happened because of their ingenuity, of those women's ingenuity. And I would like to just mention two examples who truly changed the face of astronomy. And the first one is Henrietta Levitt. Henrietta Levitt was working on cataloging stars in the Small Magellanic Cloud, and she noticed a large number of a certain type of variable stars called Cepheids, that they were concentrated in the vicinity of the galaxy. After measuring the periods of the Cepheids and the relative brightness of each, she found a relation between the period and apparent brightness for all of those stars, in the sense that stars with longer periods were brighter than stars with shorter periods, making the reasonable assumption that the Small Magellanic Cloud is far enough away, so more or less all those stars were approximately at the same distance. She built a relation between the period and absolute brightness, which actually led to a period luminosity relation, a relation that links the luminosity of pulsating variable stars with their pulsating period. And that actually helped us determine distances through this equation here. This is known as Levitt's law. It has been confirmed by other means, and it's still being used to measure distances in nearby galaxies and in our own as well. So Levitt's laws, because of Henrietta's very careful and precise measurements of those stars, and actually her thinking abilities, now we can actually measure distances in the nearby universe, which is an important step in the distance ladder in the universe. The second woman I want to highlight is Cecilia Payne-Gaposchkin. Cecilia was not one of the women computers, but she was a very hardworking woman who was actually studying spectra and was trying to assess the chemical composition of the sun and stars. Actually, when Cecilia Payne began her study of stellar spectra, scientists believed that the relative abundance of elements in the atmospheres of the sun and the stars were very similar to that in the Earth's crust. They had no other reason to believe otherwise. Now, when she was studying stellar and solar spectra, she discovered that the sun and stars are made mainly of hydrogen and helium. And she established a scheme classifying stars according to their temperature. By calculating actually the abundance of chemical elements from stellar spectra, her work began a revolution in astronomy. Her discovery of the true cosmic abundance of the elements profoundly changed what we know about the universe. We now know that the fraction of chemical elements in the Milky Way galaxy are about 74% hydrogen, 24% helium, and 2% of everything else. But because of her discoveries, she's one of the most influential astronomers of our times. Her 1925 thesis entitled Stellar Atmospheres was famously described by astronomer Otto Struve as the most brilliant PhD thesis ever written in astronomy. So now we know that her work was correct and accurate, although contemporaries, including her thesis advisor, did not want her to publish her thesis because they thought that her discovery was ridiculous. And what do you mean in hydrogen and helium? I'm going to jump on a different field for a second because Rosalind Franklin was one of those very special individuals who was never really recognized. She was a pioneer of the study of molecular structures, and pretty much she received recognition among scientists for her research on the structure of viruses and the DNA. Her X-ray diffraction images of DNA actually, there's stories out there that they were not exactly shared, that they were sort of stolen by University of Cambridge, Francis Crick and James Watson, who claimed discovery of a double helix structure, although she did make the discovery before that. Rosalind Franklin had a very short life. She died from ovarian cancer at the age of 38, 4 years before the award of the Nobel Prize to Crick, Watson, and Wilkins. She wasn't even mentioned in their acceptance speeches. It's actually sad that she's recognized now for that discovery, but still, back in the time, people didn't want to admit that a woman was so brilliant and so accomplished and made such a revolutionary discovery. I will move forward to your own country. Janaki Ammal, I don't know if you know her, but she's India's first female plant scientist. She developed several hybrid species still growing today in different parts of the world. And her most notable work involves studies of sugarcane and eggplant. She also worked on cytogenetics of a range of plants, and she co-authored several papers and different studies. She also advocated for protecting the biodiversity of India. She was very interested in ethnobotany and in plants of medicinal and economic value for the rainforests of Kerala in India. And she was actually awarded the Padma Shri by the Indian government in 1977. So when we're looking at women in science all over the world, let's not forget our own home countries, right? I'm going to move forward and introduce Hedy Lamarr to you. And Hedy Lamarr is a very interesting person to know because she was Hollywood glamour, one of the most accomplished actresses in Hollywood. She was a supermodel. She was famous. She was rich, but also she lived around the time of World War I and World War II. And towards the end of World War II, she discovered and developed a secret communications system, a patent for an idea of a radio signaling device, which was meant which was a means of changing radio frequencies to keep enemies from decoding messages. This system became a very important step in the development of technology to maintain the security of both military communication and cellular phones, and actually is the precursor of wireless Wi-Fi and Bluetooth that we're enjoying right now. So let's go back to individuals who contributed closer to physics. And yes? Any questions? All right, so I talked about the earlier algorithm. I want to introduce Rear Admiral Grace Hopper, who was working in the Navy as well. And she was assigned to write programs for Mark I, which is the first computer, which looked like that. It was like a huge, huge wall. And she was writing these kind of software in order to run ballistic problems for the Navy. Her work on Mark began her career as a computer scientist, and actually she was developing different ways of programming computers. She reimagined programming as a user-friendly language. She actually wrote the first compiler. She developed programs for other machines. And actually, some of the programs that she wrote led to the creation of COBOL, which is a programming language that is actually being used these days. When it comes to the post-World War II era, it was very interesting to see how women were considered as part of the scientific slash development community back then. Software engineering was considered to be a women's work because it was thought to be clerical. It was so interesting. Hardware was considered to be a difficult job. So because it was a difficult job, it was for men. And actually, this is an article from Cosmopolitan in 1967 talking about the computer girls. And actually, Admiral Grace Hopper said women are naturals at computer programming. But what she was talking about was that the responsibilities women were socialized in actually made them perfect pretty much for attention to detail, for decoding for decoding programs, for actually building algorithms. And this is a room from the computer room at NASA. So at that time, NASA started exploring its own space program, and they needed lots and lots and lots of calculators. This was the Langley Memorial Aeronautic Laboratory at Pearl Jam. And this is, again, a computer room, and this is the computer. It was really very interesting. The idea for these women working there was that they would process all the data coming in from all kinds of tests and flight tests and actually come up with results. And at some point, the human computers, those women, have become essential to operations at the NASA Center. Actually, a memo that was circulated in April of 1942 said that the engineers, the men engineers, admit themselves that the girl computers do the work more rapidly and accurately than they could. So a little bit of recognition here on hard work. But truly, this is when women actually started becoming extremely key, extremely central to the space program in the United States, because all those complicated calculations, how are you going to get people to space, how are you going to launch rockets, were happening through those women. And I would like to highlight one of them, and this is Katherine Johnson. Katherine Johnson came to the NASA headquarters as a human computer, and she eventually joined NASA's Space Task Force. By 1958, she became an aerospace technologist, and she was calculating trajectories for some of the Mercury missions, including actually MA6, which is John Glenn's first orbital flight. She calculated the first path for the first manned mission to the moon. And actually, story tells us that, a big warrior of the calculations, Glenn famously said, John Glenn, get the girl to check the numbers, referring to Johnson and trusting her to make sure that all calculations were correct before he took off. She actually lived enough until 2020. She died of more than 100 years old, 102 years old. She lived long enough to actually see the evolution of computers. And I'm pretty sure it was really very satisfactory to her to see that her hard work was really paved the way for the extensive space program that we have here all over the world. So speaking of space program, Mae Jamison. Mae Jamison is an American engineer. She's a medical doctor and a NASA astronaut. She became the first Black woman to travel into space, and she served as a mission specialist aboard the Space Shuttle Endeavour. After she retired from NASA's space program, she became a professor at Dartmouth College, And now she is a member of, she's a professor actually at Cornell University, and she was advocating strongly in favor of science education and getting minority students interested in science. Here's another amazing woman, astronaut, uh, Kalpana Chawla. She is an astronaut of Indian origin, and she's the first person of Indian origin who have forayed into space. She first flew on the Space Shuttle Columbia in 1997. She was a mission specialist and primary robotic arm operator. She was actually operating these big robotic arms outside the space shuttle itself. She moved in the United States in 1982, and she got a Master of Science in Aerospace Engineering from the University of Texas, and she got a Master's and a PhD in Aerospace Engineering from the University of Colorado. She was one of the crew members who died in the Space Shuttle Columbia disaster in 2003. And this tragedy occurred when the space shuttle disintegrated while returning to the Earth atmosphere. But do not forget her face or her name. She was an amazing individual who left a huge legacy behind her, and she is a role model for many of us. I'm going to move to a different field here. Hayat Sindi. Hayat Sindi is a medical doctor, and her major contribution was medical testing, biotechnology. She's famous of actually coming up with point of care testing that actually helped capturing medical information for specific patient healthcare needs. So this is where a patient's record is a document. It was documented. It included details about the care progress. It included medication and process. And actually, this is helping even now doctors and nurses to make sure that they know somebody's medical history and they move forward very carefully to when it comes to prescribing medication and recommending cures and leading to cures. But back to space. This is Gladys West. This is an American mathematician, and she is known for her contributions to the mathematical modeling of the shape of Earth and her work on the development of the satellite geodesy models that eventually were incorporated in the Global Positioning System, GPS. Actually, GPS is essential right now for anything and everything that we do. So thanks to her, we made a lot of progress to actually improve and devise this kind of technology. The last person I would like to highlight is a personal favorite. She's one of my shearers and a very, very dear friends. And this is Dr. Wanda Díaz-Merced, one of the most noteworthy and amazing individuals I've ever met. And I really hope that you will get to meet her at some point. Wanda was born in Guarabo, a small town in Puerto Rico. In middle school, she entered the school science fair where she won second prize, and that was a turning point for her, as this made her realize that pursuing a career in science was something that might be attainable, might be possible for her. Now, what's special and different about Wanda is that she lost her eyesight. She became blind in her early 20s as an undergraduate at the University of Puerto Rico because of some kind of a degenerate disease that she had. Nevertheless, she went on to receive a doctorate in computer science from the University of Glasgow, and she studied space data analysis, something that she continued as a postdoctoral fellow at the Harvard-Smithsonian Center for Astrophysics. Wanda's big contribution was the sonification of data, a way to turn huge data sets into audible sounds. She gave actually a TED talk, How Can We Hear the Stars? She realized that as a person who does not have a vision, she can recognize and she can use their ears to recognize and detect patterns in radio data. And she can actually uncover connections obscured by graphs and visual representation. So we're talking about a person who has discovered a new technique And this is actually a spectrum of sonification of X-ray data. Because right now we're using it. A new technique for individuals with less than optimal eyesight to contribute to science. And not only that, contribute uniquely, because we know that when we're losing one of our senses, other senses become much stronger and much more optimized to help us live. My point here is that there are hundreds, thousands women in science today. And, those individuals are not necessarily appreciated and known. But, for us to know them, appreciate them, celebrate them, and build on their success is the way to move forward and provide a much more equitable world. This is actually the theme for the International Women and Girls in Science: equity, diversity, and inclusion. And this theme is built around water. Water is, as I mentioned, essential for everything. And sometimes we take it for granted, clean water. And if you want to learn a little bit more about, the science behind water, either the one that falls from the sky or the ones that we're using from rivers or the seashore, the AMS, actually, American Meteorological Society, has a series of webinars, one of which is called Science is for Everyone, Water, Friend or Foe. And it's actually the most recent one that we had back, I think it's a month old now, so it's not very old. Not even, February 9, 2022, here we are, where we're discussing all aspects of water. This is part of our citizen science initiatives, and actually we do have a whole series of webinars that touch upon all kinds of aspects of citizen science, instructing individuals on the science of weather, water, and climate. If you are interested in learning more, we have what we call a weather band. This is pretty much our webinar series. And overall, if you want to learn more about the American Meteorological Society, we have a very rich webpage with resources there that are open for everyone. Just check us out, join, get involved. We are trying to make our world a better place. I'm going to leave you with a final thought here. And this is pretty much an image that has inspired both myself and many astronomers and many women scientists in our quest for knowledge and for making the world a better place. This is one of the most admired space images ever. It's called a pale blue dot, and it's a picture of planet Earth. This little thing here, it's not a dust speck on your monitor. It is actually our planet. And it's seen against Jupiter. The very first version of that was shot by Voyager 1 about 30 years ago. And this is Cassini's version from 2013. And actually, Cassini captures some of Jupiter's beautiful rings and part of the planet. Both times, the photo was inspired by Carl Sagan's 1994 book entitled Pale Blue Dot, A Vision of a Human Future in Space, where he writes, "Look again, that dot. That's here, that's us." And he goes on to describing Earth as a mote of dust suspended in a sunbeam. It just sums up perfectly the profound perspective that we're gaining from the exploration of space, from exploration of stars, from the exploration of the universe, and confronts us with a very powerful recognition of who we are and where we belong. This picture is most relevant today than ever. When we're thinking about space, we're thinking about astronomy, we're thinking about exoplanets and exoplanet habitability in astronomy. We need to remember that the next nearest possible habitable planet is at least 25 trillion miles away. 25 trillion miles. There is no Earth 2.0. So we need to take care of this one. And water is one of the most important elements that help life and help civilization to advance on this planet. So with that, I would like to thank you for your attention and ask if you have any other questions. And again, wish everybody a happy International Women's and Girls Science Day.
Thanks, Stella. Thanks so much for a lovely talk. And I'm an ardent Carl Sagan fan. I think a lot of us from the similar generation all have been inspired by his work. And thanks so much. That was a really nice talk, very nice one. And I would now open the floor for questions. So, like
And
I typed, if you want, you can type your question. If you'd like to unmute yourself, you all are most welcome to unmute yourself and ask questions, or you can type it. So, let's start with questions. Yeah.
before we go to questions, as I said, I kind of digressed a little bit from the subject, but we need to remember that astronomy is and space science is a science that was that needed a lot of preparation in order to thrive as a science itself. It started as calculations. It started as the women computers at
Yeah.
Harvard, and even before. And then it went to computer modeling, and then it went to the space era. And because of that, and because men didn't want to do that work, that gave opportunities to women from all kinds of backgrounds and professional preparations to shine. The
Mm-hmm.
reason why I showcased Hedy Lamarr is because, again, she was one of the most beautiful, successful, amazing entertainers. Again, the peak of Hollywood, right? Celebrated everywhere. But brains and beauty go together many, many times. So do not underestimate a beautiful woman. Do not underestimate a person who does not look like a scientist. There's no
Uh-huh.
such a thing as a look of a scientist. There's such a thing as lots of hard work and brains.
That's right. Absolutely true. You've hit it on the nail. That's absolutely true. That's right.
Yes.
Because these stereotypes, I think, is what gets people, the stereotypes they have of a scientist or a woman, or, that's where the mess comes in.
Yeah. So
Yeah.
I had a discussion with a group of young women actually on how does a scientist look like, and
Mhm.
one of them described a scientist as or how does an astronomer, more, an astronomer look like? An astronomer looked like an old white male wearing a lab coat. And I was thinking, I'm not all white and male, and if I go get data wearing a lab coat, I'm gonna freeze. So you're absolutely right here. We need to step back, take a little step back from stereotypes, just dismiss them, and move forward with an open mind,
Mhm.
and embrace everybody.
That's right. That's right.
Yeah.
Very true. Very true. And the problem is we've got stuck with these stereotypes, and they get so deeply embedded in you that people think that that's how it should be. And it's, yeah, it's
But
high
I
time
think
we
that
break out from it. Yeah.
yeah, but women like you and your students and the group that is attending here are are pushing progress forward. And this is how we're going to actually get rid of stereotypes. As you know, ignore them, forget about them, move about your job, do the best you can, grow as a person, accept yourself,
Mm-hmm.
whomever you are. It doesn't matter who you are and how you look like and what your family's background is. You can do it if you work hard. That's the bottom line here.
Yeah, very true. Wise words. Yeah. So,
Yeah.
questions. Let's have some questions. That'll make it more lively.
We forgot Vera Rubin. I'm looking at the comments. We did not forget Vera Rubin. My friend Priya told me specifically not to mention women like Vera
Oh, okay. Oh,
Rubin.
I take the blame for that. Yeah.
No, I love her. So Vera Rubin is a woman who discovered dark energy, dark matter, dark energy. And I was super, super fortunate to have an office right next to hers when I was at the Carnegie Institution of Washington. She would come to the office every single day. She was one of the most humble and amazing person ever. A huge proponent of women's place in science. She would always encourage us, both female and male, and other postdocs. I was a postdoc at the time, to do our best. And she was like, if I have pictures with her, it's like I'm hugging my grandmother. She's a very wise individual. We lost her not too long ago, but
Yeah.
yeah.
So go ahead, I'll take the blame for that. I'd actually told Stella that let's not do Vera Rubin, let's not do Joycelyn Bell, let's do the
Definitely
ones that
right.
people do not know of
Yeah.
because the theme was unsung heroes, right?
Unsung heroes.
So we wanted to do that.
Yeah.
So yeah. Uh,
But Jill Tarter, she's amazing. Jill Tarter is the woman who inspired actually the movie Contact. If you guys have not seen that, just works at the SETI Institute, looking for life, trying to listen for life. Yeah,
yeah.
in the universe.
So what would be your message to young girls, young women who want to do astronomy?
Just do it. You can do it.
Yeah,
And you
that's
know, right now, if not anything else, you have the role models, you have the support group, and you're not alone.
yeah.
So just do it.
So, like Mila mentioned, yeah, I was just thinking of that. That's true that Astronomy for Outreach, IOAO, OAO office, they have announced a painting competition on how does an astronomer look like. And it would be interesting to
Ooh,
see all the entries they get in. Should
I would
ask
love to see it too.
to share the results that they get for that.
Yeah.
Yeah. So, uh, it said
There's
many
a
of these
question.
women groups also, they try to, when people draw pictures of doctors or surgeons and stuff like that, generally it's always a male, you know?
Yes, I
The nurse
know.
is a
And it's,
female and the doctor is a male. And
yeah.
again, people are
Here,
trying to break those stereotypes.
Priya, a very interesting fact. I was thinking about it this morning. All my doctors, all my physicians are female.
Oh, wow.
It's a coincidence. I didn't look for it, but when I was getting recommendations from others, and like this person, that person, and their name would not signify gender necessarily because
Uh-huh.
they don't have typical names. And I would walk in and see this amazing woman walking in the office. I'm like, now we're in business. Yes. Why would and that speaks to stereotypes that I still have, right? Biases. But we work in progress, right? We're training.
That's
There's a
right.
question in the chat. How can we connect for more webinars like this?
Yeah,
And
so
this is for you,
actually,
Priya.
sorry, like I mentioned, there's a series of 5 webinars. So today's the first, and the next following, but it's going to be on Thursdays. The next following Thursdays, 4 Thursdays, back to back, we'll be having sessions. So there'd be one on asteroid searching, on various things. So
Yeah.
you can have a look and
And you're giving one, right?
yeah, yeah, I'll give the last one.
Even like I
I'll give
remember
the
that.
last one, but yeah, I'll be giving that too. So you can have a look at them and. You can connect with us on WhatsApp or Facebook. You find me, and you'll see all the posts about it. Fine. Please ask questions.
Yeah, I just wanted to comment that
Yeah.
thank you so much, Stella, for your talk. And you mentioned Wanda Diaz and the sonification. And recently, I've been seeing a lot more sonification of astronomy events such as pulsars, and a lot of data
Yep.
from Chandra X-ray
Yep.
Observatory has been converted to sonification. So, did it originate with Wanda Diaz's ideas? Do you think this kind
Yes,
of
it did.
thing?
And actually, I do. She held postdoctoral positions at CFA for a long time. And there were people there who were trying to understand her algorithm, her algorithm work in progress. She wanted to bring data in front of as many people as possible. And, when you're looking at different wavelength ranges, you're not really sure what's going on there. She is trained in radio data. But whatever projects or programs, computer programs that she's building is applicable to others. I started seeing sonifications of visual images. People don't know how to use that data quite well because an image is a two-dimensional thing and it has and three-dimensional because of brightness. It has a lot of stuff going on, right? It's not just one object that you're following. But she did pave the way for this new technique. And I'm really looking forward to seeing more individuals being included in astronomy because they will have the tools to study astrophysics, even though they won't be able to see
Yeah.
um, through a telescope.
Actually, if you remember in 2015 when I visited CFA, when we met in 2015,
Yeah.
Wanda was also there, right?
She was
I met
visited.
her at that time. And actually, Miller, what she actually does is she's even trying to do sonification, for example, for fits. Supposing you're doing a least square fit, regression fit to a curve or something like that, then you try to, the squiggles. You want to show the how badly or well does the thing fit, right? So even that can be kind of sonified so that you can see what gives you a better fit. So if you're doing a
Perfect.
regression fit or something like that, you can change the parameters and see how does it change. Rather hear how does it change based on the the least squares. What are you getting the the squiggles in your data? So actually, she'd even shown me stuff of that kind. So it's being used not just for say pulsar data and all that, but even things like this, like for fitting functions, for showing of deviations of various things. And I think now a lot of people are trying to add on to that in different ways. But I think specifically for Wanda, it probably she has an advantage in the sense that since she originally had sight and then she lost it, so she knows how one would visualize it, right? While you and me who can see, it's very difficult for us to think how would this thing appear to somebody who cannot see, right? Compared to, but so I think Wanda, because she has this unique position of having been able to see and now she can't, she kind of can compare those capabilities and do these things better in that sense. We are kind of disabled because of our ability, because it's difficult for us to imagine how is it if you can't see it, because we're so used to just seeing it, right? So I think, but there's a lot of potential work which can be done in this specifically. Yeah, like there's even what they're doing is the tactile thing, right, where you actually use 3D printers and you do through tactile so that people can feel the surface of the moon or Mars or stuff like that. Because
very true.
that's the only way that can be done. But yeah.
There is a question here on the chat. Was there an incident in the history of science that women scientists' names were kept suppressed due to male-dominated society?
Always.
And the answer is
yes. It has always been done, and it's still being done, I would say.
Yeah, it's and that's why we're trying to recognize those individuals as much as we can now. And we are building an international community of scientists who really don't respect your gender, but they don't really care whether you're a male or a female when it comes to science. We're all collaborators, we're all colleagues. So when it comes to work, we just work together. It doesn't really matter what your gender is. And actually, not only we celebrate our differences, but we strongly believe that our differences are enriching the field. They're providing different components that make science move forward faster and in a much more with higher quality of information and tools. But we still have work to do.
There's
someone who's asking, about the telescope. Sorry, go ahead.
Yeah, that's a slightly random question, but
something, it depends on what you want to do. You can, I don't know, you can use any telescope for that matter to observe the night sky. And actually, if you don't want to buy a telescope quite yet and want to explore different things, you can get a nice pair of binoculars. And that would allow you to not only explore or look at pretty objects in the sky, you can actually do variable stars as well. And I'm going to defer you to Teja Begari for that, who is one of the AVSO ambassadors and knows more about how to get started in astronomy.
He'll be there in the next session, I think, right? Teja, when is nothing? It's the next one, or?
Yes, it's the next one.
That's next Thursday.
Very nice.
Next Thursday.
So tune in next Thursday. You're gonna get lots of good tips.
Yeah. So it's this. So for people who were asking, exactly the same Zoom link next Thursday for the next 4 Thursdays at 8 o'clock in the evening, the same time, but only Thursdays. Okay. So
we have 5 more minutes to go. Any last thoughts, Priya?
Yeah, so thanks, Mila. So this is the next Thursday one, which is which is citizen science projects. You'll have Amoli Kakar, you'll have Kushi Arora and Teja. All three would talk to you about citizen science projects. Yeah, thanks, Mila. Yeah, the same link. It's not for tomorrow. This is for next Thursday. Srutika, this is for next Thursday, same time. For the next 4 Thursdays, same time. I will send mail for people who registered, but it's basically the same thing. All events have the same connection. Okay.
Well, with that, I will thank you all for joining us today. It's
Thanks
been a
so much.
lovely audience. Thank you for the opportunity, my friends, and I hope to see you again soon.
Yeah. Thanks a lot. See
Thank
you. Bye, Stella. And see everyone
Bye.
next Thursday, next 4 Thursdays, 8 p.m. Same link. Thanks a lot. Bye.
Bye. Be safe.
Have a nice day. Bye-bye.